let's just take oxygen, for example. No, let's do something smaller.
Hydrogen?
Well, we'll do oxygen right now. So oxygen would be an atomic particle, right?
Yes.
So if we're talking subatomic, particles, we're talking about the small particles that make up an atomic particle. So with an oxygen, we know that there's going to be 8 protons, 8 neutrons, and we can guess there's 8 electrons. So these would make up subatomic particles.
So subatomic, so if you were to like put it in a level system, it would be subatomic, make up atomic particles, make up molecules.
And compounds.
And compounds.
Yeah. Do you understand compounds and molecules?
I know molecules, I was just looking at it before you
So,
talking to me. And so I got the molecules are made up of different atoms. Oh wait. Molecules are the same atoms, so like hydrogen and hydrogen.
or different. They could be the same or
I
different.
thought that was what a compound was.
So a compound, they have to be different.
Because it's like chlorine and hydrogen.
Because H2O could be both a compound and...
Because it says here, molecules are 2 or more atoms combined to form an independent unit.
Yeah.
Oh, you're right, it can be 2 different compounds.
So H2O would be a molecule. Because you have like a water molecule. You hear that often, right?
So can a molecule only be 2? Oh no, it says 2 or more.
2 or more. So yeah, we could do carbohydrates, which is like, what is that? Carbon, hydrogen, oxygen.
Okay.
So that would be a molecule, carbohydrate molecule. Then compound, tell me if this is going to be a compound or not.
No,
Why not?
because it has to be different.
Has to be different, right? So that wouldn't count. If we add something else to it,
And it would be.
then it is.
So the only difference is that a molecule can be the same, whereas a compound cannot.
I think there might be one other difference. Let's look through this real quick. Not all molecules are compounds. Some compounds are molecules and some are not.
Are they not? Is the question.
Okay, so this is, yeah, I forgot this part. So compound are going to be covalent bonds. And this is why.
And covalents don't have to be match up perfect, don't they?
They have to, yeah, so they have to share electrons,
Yes.
right? So we think of covalent bonds as like a handshake. You're able to share germs that way.
Nice.
Whereas an ionic bond is more like a fist bump.
Yeah.
It's just temporary, boom, right? So this has to, as it says right here, let's see. Some compounds are molecules and some are not. Remember that to be a molecule, structure must be an independent unit. And so with covalent bonds, when they actually are formed together, it looks more like this. Whereas in an ionic bond, you're going to have 2 separate ones pretty much that kind of just are there with each other for a little bit until something bad happens, then they're gone.
Okay.
More of a fist pump than a handshake.
So it's only temporary.
Right.
Like
Yeah, so NaCl, would that count as a compound?
Which one?
NaCl?
Yes.
No.
No?
Because it's an ionic bond, not covalent. Does that make sense? So molecules, they're a little more flexible in what they can be. They could be the same. They could be different atoms combined together. They could be,
So it could be ionic or
well, I guess they can't be ionic, could they? Let's see. yeah. So covalent bonds are definitely going to be molecules, whereas ionic bonds, probably not so much. But definitely for a compound, it'll have to be.
They have to be covalent and different.
Yeah. So I'll read it one more time. It says, covalent compounds in which different types of atoms are held together by covalent bonds are molecules because of sharing of electrons in distinct units. On the other hand, ionic compounds, oh wait, maybe I'm saying this wrong, in which ions are held together by the force of attraction between opposite charges are not molecules. Okay, so not molecules. Because they do not consist of distinct units. So, yeah, I guess in talking about both of these, you're going to look for covalent bonds rather than ionic bonds.
Okay.
So the biggest difference, this is made up of different ones, made up of the same. That's probably to the extent you'll need to know it.
Okay.
If you even do need to know it.
Yeah. Yeah, we need to know.
Because I know we didn't. I asked the teacher, I was like, what's the difference? He's like, you don't need to know it. He's like, but that probably didn't answer your question. I was like, yeah.
Yeah.
At least explain it to me a little more. So.
Basically, no, our teacher said anything on the slide is game, and it says molecules and compounds, so it's going to be on the
Okay. Yeah, I just remember those few points that he has there.
Compounds are different, molecules are the same, and they're all made up of atoms.
Yep.
And atoms are made out of subatomic atoms, which are
Subatomic particles.
Subatomic particles.
Yeah, atomic particles. That makes sense? Just think subway. It's below the ground. Yeah.
Subatomic particles, which are electrons, neutrons, and protons.
Yep. That's it.
Boom.
It's easy.